Welcome back to CCNA by Objective. My name is Samuel Wireless. On this channel, we talk about networking and cybersecurity. So, as always, opinions expressed in my videos are my own and do not reflect any employers of mine, past, present, or future. Just want to make sure I get that out of the way. So, going over to CCNA by Objective here, we're on 1.4, identifying interface and cable issues. So these can come in the forms of collisions, errors, maybe a duplex or speed mismatch. And I want to talk a little bit about that. There's not a ton to talk about here, so it'll probably be a pretty short video. And I want to kind of focus a little more vendor agnostic as opposed to a little more Cisco-esque as I would if I was teaching a full-fledged CCNA course. So when are we going to have these collisions and errors, and why? How can we track this down? How can we trace it back to the actual root cause? Well, sometimes it's just going to come down to the cabling. Now, we have, when we're talking about copper, this is a Keystone Jack, so this is what would go fit into your wall plate. So there's all these different pins in here. And if you're familiar with copper Ethernet cabling, Cat5, Cat6 cabling, you would kind of recognize this. And these are the different pins that would connect to the actual wires in your Cat5, Cat6 cabling. In this case, this is a Cat6 Keystone Jack, but it's very, very similar when we're talking about other standards here. The same kind of pinouts are going to be on the back of patch panels. If you have a patch panel, on some patch panels actually fit Keystone Jacks, so you can put these in here and punch them down outside. Now you can use tools like these. This is a toner and probe from Fluke. Big fan of Fluke. They make some really solid tools. Have really good success. They have some cheaper ones out there that aren't Fluke branded. So if budget is a huge concern, that is a possibility. Although I would highly recommend these tools specifically are very versatile and still relatively affordable. There is the Link Runner, which I believe is owned by I think they're owned by NetScout. I think they're owned by NetAlly now. They keep changing the name, little branding here and there. But Fluke sold that line a while ago. The Link Runner AT2000 was a big helper for me. Now that belonged to my job. It's kind of an expensive tool. I never purchased it myself, so I don't have it anymore because I left that previous job where I was using it. That's also a very nice tool if you can afford it. But this toner and prober, it does a few different things here. So first of all, we can actually test the cable. And you can see there's 8 different indicator lights here. It'll cycle through each pin and light up in order. It'll have different kinds of beeps depending on if maybe there's an issue with that particular pin. And then we can go back to our Keystone Jack, right? And we can go and punch down that pin again, maybe see if that helps the connection. Maybe we can cut off the end of the cable and re-terminate it onto our Keystone Jack if we're having some cabling errors and such. One thing to note, when we're talking about our copper cabling, there's a lot of things that go into that and that can affect that. We might not make the first decision to go and chop off the end and re-terminate. But termination is just really connecting these pins here to the actual copper cabling, right? So in the case of Keystone Jack, you'd use a punch down tool, right, and kind of do this. Now in the case of if you were just putting an RJ45 end directly on there, then you would be using a crimping tool to crimp that on. I should have grabbed that from the bag. I didn't. But so, there's a few other things that could be besides maybe a misconnection. Maybe you have a bad cable, right? So typically you would have a patch cable going from here, from the wall to your end device. You'd also have a patch cable on the other side going from the patch panel to maybe a switch. And there could be bad cables in there too. So we can use these again to test A to Z, right? The cable, the end to end. This also has coax connections, so you can connect that. And if you're doing kind of some more manual stuff, there's some manual connections to do analog stuff as well, which I have actually never used in production. I do have an analog one of these. This is digital, so that helps in a couple of ways. For example, we can actually make the switch light blink, which is going to help us, maybe if it's already plugged into a switch, we can make that light blink at a different rate so that we can then walk over to the switch and see the funny blinking of a particular option there. The other thing about this probe here is this is going to send out a digital signal, which is going to be better and stronger than an analog signal if you're looking at an analog set. They're a little cheaper for analog, but digital is a lot more reliable. And I can pick up that digital signal with this. So maybe the cable's not marked. I can plug this into the endpoint side, and I can take this back to my network closet, back to my IDF, and I can kind of scan it around until it starts beeping. Now, these lights, instead of being pins, are going to be my levels, right? So it'll kind of go up as I get closer, and I'll be able to go and confirm that's the right cable, eventually using this to test and make sure all of my pins are good on the pinouts, making sure they're in order, making sure that they work, right? All those things. Now, we may not want to jump to that conclusion first off, because maybe we're not close to that site. So what we can do when we're looking at these collision errors, mismatches, and stuff like that, we can go into our switch settings and maybe look at our port. Is it manually configured? Should it be manually configured? So one of the weird things about 100 meg by default, 100 meg is half duplex. So if you're not negotiating on one of the sides and it's 100 meg, but you're not negotiating duplex, the other side will assume half duplex. So if you have on one side 100 meg and full duplex, and then the other side you have 100 meg and auto duplex, then it's going to do half duplex. And then when you come together, there's going to be a duplex mismatch, which is going to give you collisions, right? It's going to give you port errors. And you can show that depending on your manufacturer with maybe a CLI command. Maybe you'll get alerts and other things. So that's another one, is kind of a mismatch between the two ports. And you can check that out, especially if it's a specific device. Maybe if you move it to another port, you find that it's still not working correctly. It's either, hey, maybe it's a cabling issue, maybe it's this particular device. Especially if it's something new, or maybe sometimes it's usually best practice to do everything auto configuration wise, but some people are going to do it manually for stuff like servers. And I've seen that in the past where they'll go and manually configure speeds and stuff on servers. And I guess they think it's more reliable, but I don't usually go down that road myself. We talked about cabling issues. We talked about mismatches. What are kind of some other things that could cause these errors? So if we're talking about copper, again, you could have EMI, right? Electromagnetic interference. Sometimes I've seen cables that run over like electrical ballasts for your lighting, right? And that can cause a lot of issues there. Kind of some weird, awkward issues that, hey, it's only when the light's on, and it's only during these times of day. Kind of reminds me of the example of when, someone was turning on a microwave and that was emitting 2.4 gigahertz radiation, which was causing issues with the 2.4 gigahertz Wi-Fi. And it's like, oh, our Wi-Fi between like 12 and 1 really is not working well. But anyway, so you can have some different interferences there. There's different ways we can combat that, right? Obviously, hopefully we have professionals installing our cable that are not going to do something like that. And we're going to make sure that in our cabling standards, all of our cables must be run separate from any electrical, any lighting, wire, anything like that. Even if it's low voltage. I had a situation where I was working on a construction project, and some low voltage guys came in, some electrical guys came in, and they were running low voltage for the lighting. Right, so it's kind of like a new LED style lighting, and it was low voltage. So they said, well, low voltage, we'll run it with the other low voltage, the network cabling. And so they used the existing ceiling hangers that my cabling guys were using. And we found out, we shut it down. They're like, no, you can't do that. You're going to have to run your own hangers. It's all in the specifications. It's all in the bid that went out. You need to run your own hangers. You can't piggyback off of ours. Because even though today you're running low voltage, today there's not going to be any issues, right? I don't want there to be any question there. So the last thing we want to do is have a network issue, and now we're ripping up the ceiling, tearing up the lighting and other stuff. Let's just run it separate and make sure that we're doing everything the best that we can. Some of the other things we can do, maybe we can run our cabling in some conduit. Maybe we can run shielded cable if there's a particular instance. Usually, and this is like if you're doing some remodeling work and there's not really a lot of space to run cable, sometimes you don't really have as much choice. Just make sure you're grounding that outer shielding. So you do need shielded connectors on each side for that to be completely effective. Another thing to notice there is these probes become almost useless with shielded cable. You're only going to be able to tell at the end of the cable, not along the cable. So keep that in mind, because that shielding is going to protect that and keep all that signal inside. You're not really going to be able to use this. So the last thing is a port issue, right? So we could have a port issue on our switch, which I've never seen in production, but could happen, right? The switch port could have an issue that's spitting out a bunch of junk and causing collisions. Maybe the end device is doing that. Maybe there's stuff like runt packets, which are packets that are too small, or runt frames, really. We're talking about layer 2 at this point. So there could be runts that are coming on. They're too small. They're not full. It's not the entire frame that we're looking for. It's a partial, and that could come down to, again, kind of the issues we talked about. Maybe it's also a port malfunction on the server side, the client side, something like that. Now, again, sometimes these things are kind of difficult to come to a conclusion very quickly. And so it may be the case of, hey, well, maybe we want to go ahead and find out what's the thing that we can do to eliminate that the quickest and the most cost effective. So especially if you're very distributed in your network, say all your IT people are, here in Texas, and, maybe you're distributed across the whole US, right? You don't necessarily want to fly someone out, spend several $100s just to have them run a cable test. Maybe you want to go and ship them a new laptop, or have them switch laptops or switch ports in the wall, and try to see if that helps. Little things like that can really save you money and time as an IT professional. So, keep that in mind. There may be some situations where, hey, it looks like it's this, but we're going to try these 3 things first, just in case, just so that we are making sure that we're using our time and our money efficiently. I think that's really it. In terms of fiber, usually what we're dealing with is the ends. We're making sure the ends are clean. So there's a cleaner you can get. It kind of looks like a little punch down tool where you can go and clean the fiber there. Kind of punch it, and it'll shoot some air in there and get any little dust and debris and stuff out of there. If you're dealing with port issues on your fiber, I know I talked a lot about copper, but not really fiber. Other than that, that's pretty much it when it comes to that objective there. So tell me in the comments, have you experienced any issues before? Most of the issues I've experienced in the past are just mismatches, right? Somebody configured something manually, and maybe a switch port was changed or a switch was replaced, and that wasn't carried over. That's most of the issues that I've seen in production. I haven't had any ports fail on me. We had a good refresh cycle at most of the organizations I was with, and so we didn't have really old equipment. But especially if you're running equipment for an extended period of time, you may have a higher failure rate, and you may see that more often. Or maybe you're running a lot of equipment, right? Maybe you're running 10,000 servers, and then of course your chances just go up just by sheer volume there. So let me know in the comments if you've seen any of these issues before in production, how you solve those problems, and I'll see you guys in the next video.